what I would like you to do is on your graphing calculator, graph x squared plus x minus 6. And these are the things that I want you to think about. When is f of x greater than 0? How would you write your answer in interval notation? And what were the most critical points when you considered your answer? So go ahead and graph it, and then you can work together as a pod to answer those questions. Anytime I say graph something again, Okay, I'm hearing our conversation drift away from math. Does that mean you are finished with this, or does that mean you are distracted? Okay, how many groups need more time? Okay, Connor. When is f of x greater than 0?
From negative infinity to 3, and then you add like 2 to
From negative infinity to 3?
Negative 3.
Okay.
Negative 3.
And then again from 2 to infinity, is that what you said? Would you agree with Connor's description?
Yes.
Our function is greater than 0. Did I do the right parentheses brackets?
Yeah.
Okay, okay. Our function is greater than 0 when we are above the x-axis, correct? Okay, so what were the most critical points when you had to look at your graph and determine
The x.
the x? What else do we call those? Our zeros. Man, have we been doing some work on finding zeros? Yes. Okay, so we are going to be solving inequalities that are not linear, okay? We know how to solve a linear inequality. We did that, what? Algebra? Algebra 2? Can't remember which one. Maybe a little bit of both. Okay? But now we're going to get inequalities that deal with other types of graphs. In particular, polynomials and rationals. That's what we're going to work with today. Okay? So if we have a polynomial graph, and we know where it crosses the x-axis, then we can figure out, is it above or is it below our x-axis, and figure out how to answer the question that they've given us. Okay? So here are the steps that we need to take to solve a nonlinear inequality. Okay? We need to to determine our critical values. You decided as a class, Gabe offered up, it sounded good to the rest of us, that our zeros are our critical values. Okay? That is what's dividing the graph from being either positive or negative, potentially. Okay? Now, we don't always have to graph it. We can think about our graph. We can also do what I call test intervals. Okay? We know that between two zeros, as long as we've found the zeros, between two zeros, the graph is either going to be all above or all below the x-axis. Okay? It's not going to cross anywhere that we haven't found. Okay? So what we can do to test intervals is we can use our zeros and we can evaluate the function in between our zeros to figure out, are the values positive, are the values negative. That way we don't have to take the time to graph. You can also think about the graph, but this is a way for sure to know if you have positive or negative values. And then we're going to represent our answers two different ways. We're going to represent our answers on a number line as well as in interval notation. So we're going to do an example, and I'm going to talk about testing intervals. I'm also going to talk about how you can think of the graph to determine where our function is positive versus negative. Okay. You want to keep in mind that you want your function to be compared to 0 before you start finding critical values. Okay. We can't find zeros unless our function is set to 0, so that's going to be our first initial step before we go into these up here. Here's the inequality. Now, to find critical values, we need our zeros. Okay, so before we go any further, we need to make sure that our inequality is compared to 0. How do we do that? Let me just try it out. Okay, let's add the 4 over. So we're at x cubed minus 4x squared minus x plus 4 is less than or equal to 0. We want to know where that polynomial is less than or equal to 0. So really we're figuring out where this polynomial is either at or below the x-axis. Right? That's what that means. Okay? So let's find our critical values. Okay? X cubed minus 4x squared minus x plus 4. It is okay to turn this into an equation to find your zeros. I actually prefer you to turn it into an equation to find your zeros. Right now, that inequality sign does not matter. I just want to know where we cross the x-axis. How are we going to solve for our zeros? We can always look for factoring by grouping if it is an option. Okay, so GCF of the first two, left over is x minus 4. What do we need to factor out of the second set? -1, left over is x minus 4. So we can factor out an x minus 4, left over is x squared minus 1. And what can we do with x squared minus 1? Okay, we have a difference of squares. So x plus 1 and x minus 1. So our critical values are 4, -1, and 1. What I'm going to do is I'm going to draw maybe a little bit more level of a line. Okay, I'm going to draw a number line here, and I'm going to place -1, 1, and 4 on our number line. I'm going to show you first what it looks like to test intervals. Okay. Since we have 3 zeros, we have 4 different chunks of the graph to test. Okay. What is a number between -infinity and -1? -2 would be a number, right? So let's plug -2. And I'm just going to write like a little x equals -2 right here. You don't have to, but that's what we're doing. We're plugging -2 in to our function. What do we get? We get -8 minus 16 plus 2 plus 4. Wait. Yes. So is that a negative or a positive number? We have -8 minus 16 plus 2 plus 4. Wouldn't that be negative? Okay. So is that number less than or equal to 0? It is. Okay. Which means all of those numbers work. What's a number between -1 and 1? 0. That's where that falls. What do we get when we plug in 0? Is +4 less than or equal to 0? Okay? That does not satisfy our inequality. So between -1 and 1, that's not going to work. Those values are above the x-axis. Okay? Between 1 and 4. Let's try 2. So we get, when we plug in 2, we get 8 minus 16 minus 2 plus 4. That is a negative number. Do you agree? 8 minus 16 minus 2 plus 4. Okay. So that is a negative number, which satisfies our inequality. So we know between 1 and 4 will work. Now we're going to try after 4. 5 would be the best number to choose. Okay, if we plug in 5, we get 125 minus 100 minus 5 plus 4. That is a positive number. It's not going to satisfy our inequality. Okay? Now my second question for you, do the zeros satisfy our inequality?
Yes,
Why?
because it's equal to as well as.
We have that equal there. So when we write our interval notation, okay, we have an interval from -1 infinity to -1, so we will include -1, and we also have an interval from 1 to 4, so we will include 1 and 4. Also, we need to do that on our number line. We want to bracket at -1, +1, and +4. This is what your number line answer looks like. This is what your interval notation answer looks like. Huh? Yeah, this is me shading it in. And you can just like darken it, you can do, like I did a squiggle here so you can really tell the difference. Whatever you need to do to make sure that I understand that that is shaded there. Okay? Now, did anybody think about the graph as we did this? With polynomials, okay, I am okay if you consider the graph, right? Okay. We know that these are our 3 zeros, correct? And we know we have a positive leading coefficient and an odd degree. And all of our zeros have multiplicity of 1. And so we know that we are below the x-axis from negative infinity to negative 1, as well as 1 to 4. It is okay to think about the graph for those polynomial inequalities. Okay? If you do that, just do a rough sketch of the graph so I can see that that's what you thought about, and then give me your intervals. Okay? The problem is it's not quite as nice to do that for the rational functions, and so that's why I want to teach you the testing intervals. But for polynomials, if you want to think about the graph, you go for it. Okay? It's probably going to take less time. Do you agree? Okay. For lunch, we'll get through as much as we can. We might be able to get through the entire example, I'm not sure. But I want to talk about a rational graph. Okay? Here is my function. I want to know when it is greater than 0. So what I want you to do is write down in interval notation your answer. When is this graph greater than 0? Write it in interval notation and then compare it with your neighbor. I do want to hear some talking. Okay, pod 7, where are we greater than 0?
Negative infinity to 5, and then 2 to infinity.
Negative infinity to where?
Negative 5.
Okay. Right? That's negative 5?
Yeah, negative 5.
Okay. Like this? Okay. Now, we have 2 intervals, but we only had 1 0. What else is critical? Your vertical asymptote. Okay? Your zeros obviously break your graph up into a positive versus a negative portion. But your vertical asymptote will also affect the behavior of your graph. Notice how here we have negative values, but on the other side of the asymptote we have positive values. So when we go to solve these inequalities with rational expressions, we're going to have to think about not only the zeros, but also the vertical asymptotes. Okay? Here's our first, well, here's our example. Okay? So So the process is still going to be the same, but our critical values are going to include zeros and vertical asymptotes. We'll switch it. Okay. Now, this rational function, what is it being compared to? 3. What do I want it compared to? 0. Our first step is to make sure we're being compared to 0. So 2x minus 7 over x minus 5. We're going to subtract 3, and now we're less than or equal to 0. Why did I leave a big space there? Careful. We want one big fraction, right? So we need to make sure this second term has a common denominator, okay? Our common denominator being x minus 5. We want to be able to actually perform the subtraction, so we want to make sure both pieces have the same denominator. Okay? So we have 2x minus 7 over x minus 5, and we're subtracting 3x minus 15 over x minus 5. Please, 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 please be very careful when you subtract. Our numerator becomes 2x minus 3x and negative 7 minus negative 15. Positive 8. Okay? And our denominator, of course, is going to stay as x minus 5. Now we can figure out where this is less than or equal to 0. Okay? So our critical values okay? Two things to consider here. The first is our zeros. So you can take your inequality and make it an equation so we can figure out where this is 0. What happens when you multiply this over? Goes away, right? X minus 5 times 0 is 0. So we're really just looking at where that numerator is 0. So x equals 8 is our 0. I also told you, or we also decided that vertical asymptote was important. Where is it at? X equals 5. Do not forget that a vertical asymptote is a line. You have to write it as such. Okay? So, we have two critical values. We have a critical value of 5 and 8. Okay. We're going to get this done, guys. What's a number between negative infinity and 5? That would be nice to plug in.
0.
Oh, always choose 0 when you can, okay? When we plug in 0, we are left with 8 over negative 5. Does that satisfy our inequality? Excellent. Between 5 and 8. 6 would probably be the easiest. Let's see, we would get 2 over 1. Do you agree with that? 2 over 1? Is that less than or equal to 0? Nope, doesn't work. Above 8, just make it easy and choose 9. We would get negative 1 over 4. Is that less than or equal to 0? Since it works, the whole interval works. Okay? brackets, like this. On both of them? Which one? Okay, isn't it the 5? Why does the 5 need a parentheses instead of a bracket? It's an asymptote. Can we ever include an asymptote? No. Okay, so no matter what, the vertical asymptote has to have a parentheses, no matter if there's equality or not. So our answer is negative infinity to 5 and 8 to infinity. Okay. When you get back from lunch, we can have work time on homework as well as going over the quiz. Okay, so we'll have a nice chunk of time to work on these problems as well. Okay? Enjoy your lunch.